Hi everyone, welcome to the final video in our series. Now we've talked a lot about the quadratic formula and solving quadratic equations by completing the square and all these new methods. Now in this last video we are just going to take a slight deep dive into the quadratic formula that I've got written down here. And what we are going to do is we're going to examine a small part of this and look at some shortcuts and see what that part of my quadratic formula tells me about the amount of solutions I would expect. Now, in the previous video, we talked about the idea that we had this plus or minus thing going on. So typically, we assumed that we were going to get two solutions to my quadratic equation. So two solutions for x. However, I mentioned in the last video that we don't always get two solutions. This may change, and we even saw this when we started looking at quadratic equations the first time we ever came across these. We usually got two solutions, but not always. Now, what we are going to do here is highlight one particular part of this quadratic equation known as the discriminant. Now, the discriminant is just going to be a small piece of the puzzle that we can use to figure out how many solutions we would expect. Think of it as like a bit of a shortcut. It doesn't tell us the solutions, it'll just tell us how many we expect. Now, I want to highlight just this portion here inside the square root. This guy here is what we call the discriminant. And we have special notation for that, but I'm going to make a little note here, and this is that the discriminant is, and we have a special symbol for the discriminant that we use. That's this little triangle here. So the discriminant is equal to b squared minus 4ac. So it's just the section of our quadratic formula that falls under the square root. And just this little snapshot of my formula here can tell me a lot of useful bits of information about the types of solutions I get, or how many solutions we get, I should say. Now let's consider a couple of cases for the discriminant. Now, we're going to look at one that we saw happening a lot in the previous video. And that's when my discriminant was greater than 0. So, when the discriminant is greater than 0, that means the number under my square root sign is going to be greater than 0. So, taking a look at this, an example like, I don't know, minus 2 plus or minus the square root of 7, for example, over 2. Now, 7 is in fact greater than 0. And when we have something actually in the square root sign, then that means that our plus minus thing gets applied. That means my solutions are going to be negative 2 plus root 7 over 2, or negative 2 minus root 7 over 2. So for something like this, we end up with, down the bottom here, 2 solutions. If you want, you can go back and watch the previous video where we applied the quadratic formula to solving quadratic equations. And we noticed that for all of those, the number inside the square root was positive. It was a number greater than 0. So when the discriminant is greater than 0, we get two solutions. Okay, cool. That's nothing new. We've looked at that a lot in the previous examples we've done. Now let's look at some other cases here. Next, let's look at what happens when our discriminant is equal to 0. Now, this one we didn't quite see in the previous video, so let's identify what this could possibly mean. So let's take this same example, I don't know, -2 plus or minus. This is an example of another quadratic, another expression we get when we substitute numbers into our quadratic equation. Now, here, I have the square root of 0 happening. Now, when I take the square root of 0, what number do I get? Well, I just want two numbers that multiply to give me 0. Well, that's just going to be 0, right? The square root of 0 is just 0. So that's -2 plus or minus 0 over 3. Now, have a think about this. If my number at the end here is 0, does the plus or minus section here even matter? Or does it become redundant? Now let's take a closer look at this. Whether we have -2 plus 0 over 3 or -2 minus 0 over 3, we're always going to get the same answer. -2 plus 0 is going to be -2, and that's going to be over 3. And my other one's going to be -2 minus 0. I'm just minusing 0 from -2, or adding 0 to -2. That does nothing to my -2. So I end up getting the same answer for both. Now, we've looked at some of these in the past, but this is an example of, and we'll look at this when we start going through some questions. This is an example of, yeah, we have two solutions, x equals -2 plus 0 over 3, or x equals -2 minus 0, but those solutions are the same. So we can say that when our discriminant equals to 0, then nothing really new happens for the second solution. Or in other words, I only have one solution. I only have one unique solution here. Now, one more section we're going to do here. Let's look at what happens when the discriminant is less than 0. All right, let's pick another expression. Let's say we had 3 plus or minus the square root of -5 over 2. Okay, I want you guys to grab your calculator and put this thing in. More specifically, put the square root of -5 into your calculator. And you will see something come up which says math error. And some of you may be looking at this even now and just thinking, well, how do I compute that? How do I simplify this? Can I get two real numbers that multiply by each other to get -5? I can get two numbers that multiply together to give me 5, but those will not be the same. So, for example, I can get -5 by going √5 times, I don't know, +√5, but these are different numbers. I have a negative and a positive here. So there are going to be actually no real solutions to this. I don't know about you, but so far with what we know in maths, in what we've been covering in school on this video, there are no real numbers that we know that can multiply together, that are the same, that can multiply to give me a negative. And your calculator will confirm this by giving you this math error sign. So all this means is that we have no real solutions. So this is what the discriminant tells us about the solutions we have. When my discriminant is less than 0, I get no real solutions. And we can hopefully see that in this particular example down the bottom. When we have the discriminant equaling to 0, then we get only one unique solution, or two different solutions, but they're exactly the same. So only one unique one. And finally, when my discriminant is greater than 0, I get the two solutions that we're used to getting because of this plus minus idea. And we can use this discriminant to narrow down how many solutions we would expect. So we don't have to use the entire quadratic formula. We will if we want to find what those solutions exactly are, but we can only use a snapshot, a portion of it, in order to find how many solutions we would expect, whether that's 2 or 1 or none. Now let's apply this to some questions and state how many solutions, the number of solutions we're going to get for this quadratic equation. Now we're going to be doing the same thing as the quadratic formula video that we did last time. We still want to identify my A, B, and C. And we just want to substitute this into the discriminant. So our A here is going to be 1, because remember we said in the last video, if there's nothing in front of x squared, we assume that there is a 1 there. So my A equals to 1, my B equals to 5, and my C here equals to -3. Be careful of the sign here. Now, we're going to substitute this into the formula for the discriminant. That's going to be that our discriminant, this triangle thing here, equals to b squared minus 4 times a times c. And substituting these numbers in, we get 5 squared minus 4 times 1 times -3. Okay, so it's looking like we're likely going to get a positive number. Why is that? Well, we have two negatives multiplying here, which will give me a positive. So 5 squared is going to be 25, and minus 4 times 1 times 3 is going to give us positive 12, and then we have 37. So now we want to consider our rules that we established up here, and we're going to notice that our discriminant 37 is greater than 0. So we can say here, the discriminant is greater than 0, therefore, how many solutions do we have? We have 2 solutions. So that means that when we put this in the quadratic formula, the plus or minus thing will count. So we're going to get 2 different solutions. All right, next example. We want to once again identify what all of our coefficients are. And my a, the coefficient in front of x squared, is 2. Coefficient in front of x is -3. And c is just positive 4. And I want to sub these into my discriminant. Putting all these numbers in, I get -3 all squared minus 4 times 2 times 4. Okay, so -3 all squared, that gives me 9. And minus 4 times 2 times 4, I have a negative and 2 positives. So I'm going to get a negative number here. So minus 4 times 2 times 4 gives me -32. And that is going to give me -23 as my solution for the discriminant. Now remember, the discriminant is the bit that falls inside the square root. of our quadratic formula. So having a negative number, any negative number in a square root, that's going to give us our math error. That means no real solutions here. So we can say then that my discriminant is less than 0 because of this minus in front of it, which means a negative number inside a square root, which gives me no real solutions. So we can write here no real solutions. So it's quite simple. We're just taking an easier part, a smaller bit of my quadratic equation, b squared minus 4ac, and then substituting in the values, and that's going to give us an idea about how many solutions we are expecting. All right, very last example here. I have x squared plus 6x plus 9. Now that's like saying 1x squared plus 6x plus 9. So my a is going to be 1, my b is going to be 6, and my c is going to be 9. And I'm substituting that into my formula for my discriminant. Okay. I'm going to work through this one a little quicker because hopefully by now we'll be a little more comfortable with these. So I have 6 squared minus 4 times 1 times 9. Now 6 squared gives me 36, and negative 4 times 1 times 9 gives me negative 36. And here I get a number subtracted from itself, I get 0. So we can say that the discriminant equals to 0, therefore I have only one solution, one unique solution. Now let's just double check this, because this particular quadratic equation here is one that we can quite easily solve with PSF. Now we're just going to check, because we're learning about this brand new thing. How do we know it actually works for the quadratic equations? Let's try another method to confirm that the answer it gave me was correct. So looking down here, I have x squared plus 6x plus 9. And what if I use my PSF, my finding two numbers, two factors that multiply to give me 9, add to give me 6. And I can see here that the two ones I have here are going to be the same number, because 3 and 3 add to give me 6, multiply to give me 9. So we have here only one unique solution, because the factors are the same. So this is going to be like saying x plus 3 equals to 0, or x plus 3 all squared equals to 0. So the solution I'm going to get is what we call a double root, the same solution just twice. Because if we solve this, we can see that my x is going to be negative 3 here, or negative 3, negative 3, using our null factor law up here. But no use writing that twice. I have one unique solution that's just repeated. So it's kind of weird because I have two solutions, but not two unique solutions. I only have one unique solution. So the answer is going to be the same. So we just say, in other words, that when the discriminant equals to 0, we just get one solution here. But that is how we can use the discriminant to give us an idea of how many solutions we are going to expect before we even substitute into the whole quadratic formula. But that brings us to the end of this video series. Thank you so much for joining me, and I will see you next time.